Hello and welcome back to Engineers Olympiad. We're doing the numerical questions for the topic weight volume relationships in geotechnical engineering. So let's get started. We have uploaded many video lectures before this video lecture on this channel, Engineers Olympiad. You can watch those videos before watching this video. All right. So let's get started. Question is, determine water content, bulk unit weight, dry unit weight, void ratio, and degree of saturation from the following data. Data is sample size is 3.81 centimeters is the dia and 7.62 centimeters is the height. Wet weight is 1.64 newtons. Own dry weight is 1.73 newtons and the specific gravity of soil solids is 2.70. All right. We have been given the data and we have to find certain parameters like that of water content, bulk unit weight, dry unit weight, void ratio, and degree of saturation. All right. So let's get started. What data has been given? We have been given the sample size. This is the sample size of the sampler that was used to take the soil sample of the soil for which we have to do the the computations for finding out the water content, bulk unit weight, and other parameters. All right. So this is the sample size of that sampler. All right. And we know that samplers are usually cylindrical in size, in shape. So these are the dimensions. 3.81 centimeter is the dia and 7.62 is centimeter is the height. This is the wet weight or the moist weight or the bulk weight of that soil in that sampler, and this is the weight after oven drying to remove all the water, and this is the specific gravity of soil solids. All right, the first parameter that we have to find is the water content. So let's find the water content. Water content is equal to water content, we know that it is equal to, well, first bulk unit weight or the wet weight or the moist weight, that is 1.64 newtons minus 1.37 divided by 1.37. All right, so by calculations this is equal to 19.70%. So water content is equal to 19.70%. all right. After that, bulk unit weight. For bulk unit weight, let me find the volume first. Volume, the volume of the sampler or the sample of the soil that was collected in that sampler, whose dimensions are 3.81 centimeters is the dia and 7.62 centimeters is the height. And we know the volume of cylinder, it is equal to how much? Pi by 4 d square. D is 3.81 centimeters multiplied by the height. Height is 7.62 centimeters. 7.62 centimeters. So by calculations, it is 86.83 cc or centimeter cube or cubic centimeter. All right, so this is the volume of soil sample. Next thing, bulk unit weight. So let's find the bulk unit weight. Bulk unit weight is equal to bulk unit weight. Bulk unit weight denoted by gamma, it is mass per unit volume. But which mass? Mass in the bulk state or the wet state or the moist state. So bulk unit weight is mass is how much? Wet weight is 1.64 newtons. 1.64. Volume of soil is 86.83 cc. 86.83 cc. Upon calculating, this is equal to 18.88 kilonewton per cubic meter. This is our bulk unit weight. So second parameter has also been calculated. Now remains the dry unit weight. We know the bulk unit weight. We can very easily find the dry unit weight using this equation. Or alternatively, dry unit weight is also equal to mass per unit volume. But which mass? Mass of the soil solids. That means we'll use this one. Own dry weight, because after drying in own, all the water is gone. Only we're left with the mass of soil solids, that is equal to 1.37 newtons. So it is 1.37. Volume is same, 86.83 cc. 86.83 cc. Upon calculations, it is 15.77 kilonewton per cubic meter. All right, we could have used this equation as well. We know this bulk unit weight, this was 18.88 1 plus water content, that was how much? We calculated that in the very beginning. It was 19.70. You could have used that also to find the dry unit weight. All right, any of the equations would have provided us the dry unit weight. All right, next thing is void ratio. We know the dry unit weight, we have just calculated the dry unit weight. We'll use the same equation of the alternate equation of the dry unit weight, that is this, and we'll be having our void ratio because all other parameters are known to us. This is 15.77 as calculated. 15.77. G is 2.70 as per the question. All right, unit weight of water is 10 kilonewtons per cubic meter. 1 plus E. Upon calculations, this 1 plus E is equal to 1.712, or we can say E is equal to 0.712. So we have our void ratio as well, which is equal to 0.712. The last thing that question asks us to find is the water content is done, bulk unit weight is done, so is dry unit weight, void ratio. Now the last thing that remains is the degree of saturation. Degree of saturation will be calculating from the generalized equation. ES is equal to WG. So S is water content is how much? 19.70%. G is how much? 2.70 as per the data. And E we just calculated as 0.712. So S becomes 74.70%. So we have completed question in all respects. We have calculated and found the value for each and every parameter that question asked us to find. All right, moving on to the next one. Next question is, a soil mass has a bulk weight density of 20.6 kilonewton per cubic meter and a water content of 16%. Calculate the water content if the soil partially dries to a density of 19.2 kilonewton per cubic meter and the void ratio remains unchanged. All right, so let's do this. So it says a soil mass has a bulk weight density of this and a water content of this much. So we can very easily find the dry density first, or the dry unit weight. This is, all right, this is given to us, bulk weight density 20.6 kilonewton per cubic meter. So this right here, 20.6 kilonewton per cubic meter, and the water content is how much? It is 16%. That means 0.16. So this becomes 17.75 kilonewton per cubic meter. Dry weight density becomes 17.75 kilonewton per cubic meter. All right. Now see carefully what the question says. Calculate the water content if the soil partially dries to a density of this and the void ratio remains unchanged. See, if the void ratio remains unchanged while drying takes place, the dry weight density also remains unchanged, since specific gravity of soil solids and the unit weight of the water do not change. All right, let me write it down here. If the void ratio remains unchanged, if the void ratio remains unchanged while drying takes place, the dry weight density also remains unchanged. The dry weight density also remains unchanged, since G and density of water, they do not change. All right, so the dry density, if the void ratio remains unchanged while drying takes place, the dry weight density also remains unchanged, because this factor and this factor, they do not change. All right, so this remains unchanged, because we know as per the equation dry density is dependent on these parameters. So if void ratio remains unchanged while drying takes place, the dry weight density also remains unchanged, because this and this, they do not change even if we go for drying process. All right, so now what does the question say? Now we have to calculate the water content if the soil partially dries to a density of this and the void ratio remains unchanged. So now this is my new bulk weight density. All right, so my dry density remains unchanged even if the void ratio changes. So density, dry density is same 70. First let me write the over here. All right, so here let me write it. Dry density is equal to how much? Bulk weight density divided by 1 plus water content. We have to find the water content. All right, that's what the question says. Calculate the water content if the soil partially dries to a density of this and the void ratio remains unchanged. So dry weight density remains unchanged because the void ratio remains unchanged. So new value of bulk weight density is 19.2 kilonewton per cubic meter. All right, so this is the equation, and new value of bulk weight density is 19.2 kilonewton per cubic meter. Dry weight density remains same, 17.75. So 17.75 is equal to this, that is 19.2 divided by 1 plus W. We have to find the new water content. Upon calculations, water content is 88.16%. All right, so water content after partial drying remains water content after partial drying. After partial drying is how much? It is 8.16%. Initially it was how much? It was 16% initially. Yeah, it was 16% initially. But the water content, if the soil partially dries to a density of this, it is how much? 8.16%. All right, moving on to the next one. Question is, the porosity of a soil sample is 36% and the specific gravity of its particles is 2.7. Calculate its void ratio, dry unit weight, saturated unit weight, and submerged unit weight. All right, so let's solve this question. Porosity is given. The porosity of a soil sample is 36%. That means N is 0.36. And the specific gravity of soil solid particles is how much? 2.70 as per the question. All right, so if porosity is known to us, we can very easily find the void ratio. How? Because N is equal to E is equal to N divided by 1 minus N. So E is porosity is how much? 0.36 divided by 1 minus 0.36. So it becomes 0.56. So void ratio is 0.56. Next thing we have to find is the dry unit weight. All right, dry unit weight we know is given by this formula. So dry unit weight, G is 2.7. 0 unit weight of water is 10 kilonewton per cubic meter. 1 plus E, we have just calculated 0.56. So upon calculating, this becomes 17.30 kilonewton per cubic meter. This is also done. Next thing, saturated unit weight. All right, saturated unit weight as per the generalized equation is G plus E unit weight of water 1 plus E. So saturated unit weight becomes G is 2.70, E is 0.56, unit weight of water is 10 kilonewton per cubic meter, and 1 plus E is same 0.56. So upon calculations it becomes 20.89 kilonewton per cubic meters is the saturated unit weight. The last thing that the question asks us to find is the submerged unit weight. All right, we know that submerged unit weight is equal to saturated unit weight minus unit weight of water. So submerged unit weight is saturated unit weight is how much? 20.89, and unit weight of water is 10 kilonewton per cubic meter, and this was 20.89 kilonewtons per cubic meter. So submerged unit weight becomes 10.89 kilonewton per cubic meter. All right, so submerged unit weight becomes 10.89 kilonewton per cubic meter. So we have calculated each and every parameter and the question stands completed. Moving on to the next one. All right. So the next question is, a sample of dry soil has a void ratio of 0.65 and its grain specific gravity is 2.75. What is its unit weight? Then the next part says what is added to the sample so that its degree of saturation is 60%. Without any change in void ratio, determine the water content and the bulk unit weight. Then the third part says the sample is next placed below water. Determine the bulk unit weight not considering buoyancy if the degree of saturation is 95% and 100% respectively. So question has three parts. Let's go on solving this one by one. Let's read it again. A sample of dry soil has a void ratio of 0.65 and its grain specific gravity is 2.75. What is its unit weight? All right, what is its unit weight? So let's see and find the answer. Now the question, the part one of the question says what is its unit weight, but if you can see question, or you have to be very tricky in reading these type of questions in weight volume relationships. It says a sample of dry soil. So this unit weight which he is asking us to find is actually the dry unit weight, because the sample of the soil is dry. So unit weight in this condition is the dry unit weight, which is given by G. We have all the parameters, we can very easily find its unit weight, which in this case becomes the dry unit weight. Why so? Because the sample of the soil is dry. All right, so dry unit weight is G is how much? 2.75. Unit weight of water 10 kilonewton per cubic meter. 1 plus E is how much? E is void ratio 0.65. 0.65. So dry unit weight becomes 16.66 kilonewton per cubic meter. All right, it becomes 16.66 kilonewtons per cubic meter. So part A is complete. Next thing, it says water is added to the sample so that its degree of saturation is 60% without any change in void ratio. Determine the water content and the bulk unit weight. Now water is added to the sample. It was dry first. Now water has been added to it so that its degree of saturation is 60% without making any changes in its void ratio. Now we have to determine the water content and bulk unit weight. All right. So this is the part second of the question. Here degree of saturation is 60%. All right. We'll use a generalized equation. ES is equal to WG. That means W is equal to ES by G. So water content E we know, given in the question. Degree of saturation is how much? 60%. So this becomes 0.60. and G given in the question is 2.75 over here. Upon calculating, water content is 14.18%. The next thing it asks us to find is the bulk unit weight. All right, bulk unit weight as per the generalized equation is G plus SE, unit weight of water, 1 plus E. So bulk unit weight G 2.75, S degree of saturation 0.60, 60%, void ratio 0.65, unit weight of water 10, divided by 1 plus E, 1 plus 0.65. So bulk unit weight becomes 19.03 kilonewton per cubic meter. Alright, so part second of the question is completed. We have calculated the water content and the bulk unit weight. Now the question says, after that, after doing so many changes to the sample is next placed below water. Now we have to determine the bulk unit weight, not considering buoyancy, and if the degree of saturation is how much? 95% and 100% respectively. Alright, let's do this part third. So we have two cases. Degree of saturation is first 95% and then 100%. The sample is next placed below water, and we have to determine the bulk unit weight. Bulk unit weight as per the generalized equation is how much? G plus SE 1 plus E. So let's go on substituting the values. 2.75, degree of saturation is first 95%, so 0.95 degree. This void ratio is 0.65. Unit weight of water is 10 kilonewton per cubic meter, divided by 1 plus E, that is 1 plus 0.65. So this becomes how much? 20.40 kilonewton per cubic meter. So this is the bulk unit weight when degree of saturation is 95%. Next, it says 100%. So when this becomes 100%, S becomes 1. So bulk unit, this becomes, in this case, when S becomes 1, this actually becomes the saturated unit weight, which is equal to G plus E, 1 plus E. So G is same, 2.75 plus S is 1, soil is fully saturated. The bulk unit weight becomes the saturated unit weight. E is 0.65. Density of water is 10. This is 1 plus 0.65. So this becomes 20.60 kilonewton per cubic meter. Alright, so we have calculated each and everything. We have completed all the three parts. This is done. So is this, and so is this. All right, we have calculated the bulk unit weights when degree of saturations were 95% and 100% respectively. All right, moving on to the next question. Question is, a sample of saturated soil has a water content of 35%. The specific gravity of solids is 2.65. Determine its void ratio, porosity, saturated unit weight, and dry unit weight. All right, so let's solve this question. Let's read it again. A sample of saturated soil. You have to read questions very carefully, as already discussed. A sample of saturated soil has a water content of 35% and the specific gravity of soil solids is 2.65. We have to determine its void ratio, porosity, and saturated unit weights, also the dry unit weight. All right, we know the generalized equation ES is equal to WG. First question asks us to find the void ratio. So E is WG by S. So E is water content is how much? 35%. G is how much? 2.65. And S is how much? S is 1, because soil is saturated. Very written here. Soil is saturated When soil is fully saturated, degree of saturation is equal to unit T, or degree of saturation is 100%. Soil reduces to the two-phase system instead of the regular three-phase system. All the air is gone and all the voids are completely filled with water. All right. So E is 0.92. E is 0.92. Now we have to determine porosity. When we know the void ratio, we can very easily determine the porosity. So this becomes 0.92 divided by 1.92. Porosity is 47.91%. We usually report porosity in terms of the percentage and usually use it as decimals in competitions. So we have found the porosity and void ratio. Now saturated unit weight and dry unit weight. Saturated unit weight is G plus E 1 plus E. G is how much? 2.65. 2.65. E we have found 0.92. Unit weight of water 10 kilonewtons per cubic meter, and 1 plus 0.92. This becomes saturated unit weight is 18.59 kilonewton per cubic meter. Next, dry unit weight. Dry unit weight is given by this formula. So dry unit weight becomes G is 2.65. This is 10 kilonewton per cubic meter. 1 plus void ratio is 0.92. So this becomes 1.92. So this is 13.80 kilonewtons per cubic meter. Alright, 13.80 kilonewtons per cubic meter. So we have calculated each and every parameter: void ratio, porosity, saturated unit weight, and the dry unit weight as well. With this, we have completed this question in all respects. Now let's move to the next one. Question is, a saturated clay has a water content of 13.9%. A saturated clay has a water content of 39.8% and bulk specific gravity of 1.84. Determine void ratio and specific gravity of particles. It's a nice question. It says a saturated clay has a water content of 39.8% and a bulk specific gravity of 1.84. Determine the void ratio and specific gravity of particles. So let's solve this. Bulk specific gravity or mass specific gravity is given. How much? 1.84. That means mass specific gravity, this is equal to this, bulk weight density divided by the bulk or the unit weight of water. This is how much? 1.84. Alright, so this becomes, so this is 1.84. We know this unit weight of water is 9.81 kilonewton per cubic meter. We are using this as 10 kilonewton per cubic meter for the ease of the calculations. Alright, otherwise it is equal to 9.81 kilonewton per cubic meter, or approximately equal to 10 kilonewton per cubic meter for the ease of calculations. Alright, so here I am using the 9.81 value. So this becomes 9.81 is equal to 1.84. So bulk unit weight is equal to how much? It is 18.05 kilonewton per cubic meter. All right, so this is the bulk unit weight. All right, we know water content, we can find the dry unit weight as well. Dry unit weight is bulk unit weight, that is 18.05 divided by 1 plus water content is how much? Water content is 39.8%. So this becomes 0.398. So upon calculating, this is dry unit weight is 12.911 kilonewton per cubic meter. Alright, so it is 12.911 kilonewton per cubic meter. But we have to determine the void ratio and the specific gravity of particles. Right? See how we'll be doing this. This is saturated clay. Alright, this is saturated clay. So S is 1. ES is equal to WG, or E is equal to WG. So E becomes, void ratio becomes, water content is how much? 39.8%. 0.398 multiplied by G. We have to find this, we have to find this as per the question. We have to find the specific gravity of the particles, and so we have to find E as well, void ratio. So E is 0.398 G. Let me call this as equation first. Alright, now dry unit weight is equal to this. We have found the dry unit weight by finding from this equation, because we knew the bulk unit weight, we had the water content, we found the dry unit weight. But we can use the alternate equation for the dry unit weight, that is this. And dry unit weight, as already calculated, is 12.911. 12.911. G, we don't know, we have to calculate. Density of water 9.81 kilonewton per cubic meter. 1 plus E. E will substitute value from equation 1, that is 0.398 G. Substituting value of E from equation first. Alright, so E here becomes 0.398 G. When I calculate, I get my G equal to 2.75. So we have found the specific gravity of soil solid particles, and which is equal to 2.75. The other parameter that question asked us to find was the void ratio, and from equation 1 I have void ratio is equal to 0.398 multiplied by G. Alright, over here, and G I have calculated as 2.75. So E becomes 1.094. Right, so that's how I proceeded with the question, and I found the void ratio and the specific gravity of particles. Bulk specific gravity was given, clay was saturated, and the water content was given. All right, I used this formula for the bulk specific gravity, or the mass specific gravity, which is equal to bulk unit weight divided by unit weight of water, which was this. Then I found the bulk unit weight, then I calculated dry unit weight using this formula because I knew the water content. Then I generalized the equation for void ratio, because here in this case S was 1 because it was a sample of a saturated clay, water content was known, this became the formula. Then I used the alternate equation for finding dry unit weight, because dry unit weight I had already calculated using this equation. Then I used the alternate equation and found this specific gravity, because I substituted the value of void ratio from equation 1 over here. Then I calculated void ratio from the equation first itself. Alright, so this is how we have calculated this question. Now moving on to the next one. Alright, next question is the mass specific gravity of a fully saturated specimen of fully saturated specimen of clay having a water content of 30.5% is 1.96. On oven drying, the mass specific gravity drops to 1.50. Calculate the specific gravity of clay. All right, so let's do this question. Question says the mass specific gravity of a fully saturated specimen of clay having a water content of 30.5% is 1.96. That means the bulk specific gravity or the mass specific gravity is given by G subscript M. It is bulk density of water divided by bulk density of the soil sample divided by bulk density or the unit weight of the water. All right, but here it says that it is a fully saturated soil specimen. That means for fully saturated condition, S is 1. All right, and here this is how much as per the question. Bulk specific gravity or the mass specific gravity is 1.96. All right, but we know that this bulk specific gravity is this, so this becomes 1.96. But since soil is in saturated condition, S is 1, this becomes saturated unit weight, so I replace it by saturated unit weight by this becomes equal to 1.96. All right, so saturated unit weight by unit weight of water is 1.96. That means saturated unit weight is 1.96 into unit weight of water. All right, now using the generalized equation for saturated unit weight, it is G plus E unit weight of water divided by 1 plus E. All right, so this becomes saturated unit weight is G is how much? That's what we have to find. We have to find the specific gravity of clay. So G plus E unit weight of water divided by 1 plus E. But here I replace saturated thing with this equation. Let's call it equation first. Substituting the value of equation first over here, it becomes 1.96. Saturated unit weight is 1.96 times the unit weight of water. Over here, G plus E unit weight of water 1 plus E. This and this will go. So 1.96 is G plus E divided by 1 plus E. Let us call this equation 2. All right, let's call this equation second. Now what the question says. On oven drying, the mass specific gravity drops to 1.50. So on oven drying, mass specific gravity drops to 1.50. Initially it was how much? 1.96. That means on oven drying, we know that this is equal to this by this, but since on oven drying this becomes dry unit weight, this becomes 1.50. So dry unit weight becomes this multiplied by this 1.50 times unit weight of water. All right, so let me use the equation. Dry unit weight is, as for the generalized equation, it is how much? It is G rho W All right, so here, let me drop it first because I have to do a lot of calculations. I think I'll show you first over here. So dry this unit weight becomes G divided by 1 plus E. I have to change the color. All right, this becomes 1 plus E. Dry unit weight I'll use, instead of this I'll use 1.50 as per this equation. This becomes G rho W gamma 1 plus E. This and this will go. So this becomes 1.50 becomes equal to G divided by 1 plus E. Let me call this equation third. I don't have space over here. I'll have to rub this question. Let me rub this question and write it again. Let me rub this over here so that I have space for. Alright, so I have erased this. Now also ES is equal to WG. That means E becomes how much? W and G, because S is 1. Soil is in fully saturated condition as given in the question. So S is 1. So this will become, E will become WG. So E is how much? Water content is how much? Water content is 30.5%. So this will become 0.305 G. Let me call it equation 4. We have a lot of equations, 1, 2, 3 and 4. Now let's go back to equation number 2, which is this 1.96 is G plus E divided by 1 plus E. I'll use the same equation. 1.96 is G plus E. This is as per the equation second that we had already written, divided by 1 plus E. 1.96 is as it is. Here I write G plus E. E, I'll substitute this value 0.305 G divided by 1 plus E. Again the same value, 1 plus 0.305 G. I have substituted the value from equation 4 into equation number 2. Alright. Upon calculating, G is equal to 2.77. Alright. G is equal to 2.77. Now let's assume the void ratio to remain unchanged. If the void ratio remains unchanged, then from this equation number 3, which is 1.50, this whole process took place after oven drying. So let's assume the void ratio to remain unchanged while the drying took place. So from equation number 3 over here, we'll get 1.50 is, what is equation 3? 1.50 is G divided by 1 plus E. G is as it is 1 plus E. E, we have the equation, E is 0.305 times G. So this becomes 0.305 G. So upon calculating, G from this equation is equal to 2.76. Alright, earlier we calculated 2.77. So we can say 2.77 or 2.76 is one and the same thing. So that's how we proceeded with this question. It was a long one, but a very good question. So mass specific gravities were given, and upon oven drying, this mass specific gravity dropped from 1.96 to 1.50, and that's how we arrived at the specific gravity of the clay. And we calculated this question one by one following each step, and that's how we arrived at our specific gravities, which is equal to 2.77, or you can say 2.76. All right, 2.76. 6 is our specific gravity of soil solid particles. Alright, so with this we conclude this video lecture. I hope you enjoyed this and thank you for watching this video.